Leute. Wir befinden uns aktuell in einer etwas rustikalen E737. Der Hintergrund ist, ja, wir haben nur diese Maschine zu zeigen, wie man so Cold Startup durchführt. Also das heißt also, ich starte die Maschine. Ja, ich finde das hier in diesem Tutorial. Ne? Wie gesagt, das Tutorial sind 737 Startup. Ich fange jetzt damit an. Ja, das Ganze ist ein bisschen dunkel, glaube ich. Das ist ja eigentlich egal. Ich schalte ihn automatisch. Ja,
Welcome to the 737 startup tutorial. In this tutorial, you will learn the procedure for starting a 737 from its cold and dark state, meaning all aircraft systems are switched off. We will now complete the first part of the pre-flight procedure. Normally the first officer completes this part of the procedure, but the captain may also do it if needed. We will be ensuring that switches are in the correct positions for startup. Let's begin.
so.
Verify that the flight control switch guards are closed. These provide backup hydraulic power to the rudder and spoilers if necessary. The guards are closed already, so you can simply touch or place your cursor over them to move on to the next step. Turn on the yaw damper switch. This will reduce the rolling and yawing oscillations that can occur while in flight. The yaw damper is especially important for large aircraft such as this 737. The alternate flap system provides an alternative method for extending the flaps in the event that the hydraulic system fails. We will be leaving these off for a typical startup, so ensure that both switches are in the off position. The fuel heat switches are used to heat the fuel and de-ice the fuel filter in cold conditions. The weather is fair, so set these to the off position. In normal conditions, fuel flows from the right tank to the right engine and from the left tank to the left engine. When opened, the fuel crossfeed switch allows fuel from both tanks to flow to both engines. This is useful to even out the tanks when there is more fuel in one or the other, or in the event that one engine fails. Our fuel tanks are equally balanced and both engines are working, so we'll want crossfeed off for startup. The fuel pump switches enable fuel circulation from the tanks to the engines. For safety reasons, we will be turning these off until we are ready to start the engines. The battery switch controls DC power for the electrical systems. When the guard is down, it will be forced to the on position. It should remain in this position for startup and for the duration of a flight. The galley power switch controls the galley buses, including the passenger power supplies, lights, and entertainment systems. We will be turning this on so that our passengers are satisfied and not blindly tripping over each other. The standby power system, the APU or auxiliary power unit, provides AC power for all systems besides engines. We will turn this on to complete this part of the checklist. Turn on the APU generator bus switches to supply APU power to the aircraft systems. The 737 is equipped with two fans that cool the flight deck electronic components. Typically, the equipment cooling switch will be in the normal position. In the event that one or both fans fail, the switch should be moved to the alternate position to activate the backup fans. The guard for the emergency exit light switch should always be down, which will lock the switch in the armed position. If power is lost mid-flight, applying heat to the windows before flight prevents ice accumulation and reduces the impact of bird strikes, as a warmer window is more pliable and less brittle than a colder one. These switches should be placed in the on position. The pitot tubes are devices primarily used to measure airspeed. In rainy, cloudy, or foggy conditions, water can freeze in the tubes, causing inaccurate or absent readings. The pitot static heat switches activate the pitot heater, which prevents freezing and keeps the tubes operating properly. These switches are generally kept on for the duration of a flight. When ice accumulates on the wings or engines, we need to be sure that we de-ice the aircraft before taking off and during flight so that the ice does not hinder performance. Conditions are fair, so we will not need these anti-ice switches on before startup. For maintenance purposes, it is sometimes necessary to open the ground interconnect switch so that the engine hydraulic system can be powered while the engines are shut down. We are starting the engine and not performing maintenance, so we can leave it closed. The hydraulic system provides power to aircraft controls such as elevator, ailerons, rudder, and landing gear. The engine hydraulic system should always be left on, while the electric hydraulic system should stay off until just before takeoff. The Gasper fan increases pressure. The air conditioning switches will maintain a comfortable air temperature in the cabin, which is especially important as altitude increases and ambient temperature decreases. The pack switches will activate the air conditioning. With only the APU active, we should activate only one of the two pack switches. Once both engines are started, we will have sufficient bleed air to activate both. When closed, the isolation valve switch confines each air bleed switch to its associated engine. When opened, it allows bleed air to flow between engines. In the auto position, the valve will remain closed when all bleed air switches are on, but will open if one is turned off. This can be helpful to keep bleed air evenly distributed when one source fails for any reason. We will be leaving this switch in the auto position. Engine bleed air is compressed air extracted from the compressor stage of an engine. It has a variety of uses. In the 737, it is primarily used to provide cabin pressurization as the plane ascends and ambient pressure decreases. These switches are generally kept on for startup and for the duration of a flight. APU bleed air provides air conditioning before the engine starts. It will be turned off after we start the engines, as the engines will provide all bleed air necessary. In order to maintain a safe and comfortable environment inside the cabin at high altitudes, landing lights, runway turn-off lights, and taxi lights should all be turned off before startup. Engine start switches should be turned off until we are ready to start. The gravel protect switch prevents gravel from bouncing up and damaging the aircraft's body. We will turn this off until later in the procedure. The position, anti-collision, wing, and wheel well light switches should be turned off before starting. Autopilot should be disabled entirely before startup. Ensure that autopilot systems A and B are both off. When the autopilot is on, enabling altitude, the landing gear lever should always be down while the aircraft is on the ground. On a real 737, with their guards closed, the anti-skid switches will be held in the on position. The stabilizer brake release knob, when pulled and activated, will interrupt the automatic stabilizer trim. We will now complete the second half of the pre-flight procedure. Usually the captain completes this part of the procedure, but the first officer may do it if needed. When activated, the autopilot heading mode will direct the plane toward the specified heading. Set this heading to the default centered value of 360 for startup. The altimeter uses the Colesman pressure setting, measured in inches of mercury, to calibrate its altitude. The speed brakes can be deployed to increase drag when once the engine is started, the throttle levers can be pushed. Flaps can be deployed to increase until we are ready to start taxiing. When in the cutoff position, the engine start levers will prevent fuel. We are now going to prepare to start the engines. Move the fuel pumps to the on position to send fuel from the tanks to the engines. The anti-collision lights must be turned on before starting to improve visibility for air. Trim will offset a control surface to a particular position without needing constant input from the pilot. Ensure that all trim controls are in their neutral positions for takeoff. Turn off the air conditioning pack switches before starting the engines, as we will need as much air available as possible for... We are now ready to begin the start procedure for the left engine. The engine start switch will crank the engine when moved to the GRD, or grounds position. Note that the FLT, or flight position, is only used to start an engine in inclement weather. It will provide additional power for starting the engine.